Let us consider question number 13. The wavelength of first Balmer line for H1, H12, H24 plus are lambda 1, lambda 2 and lambda 3. Then lambda 2 is less than lambda 1, lambda 3 is less than lambda 2, lambda 3 is less than lambda 1, lambda 1 less than lambda 2 less than lambda 3. Now, for the wavelength or wave number, they have written the expression 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So, this r is known as Rydberg constant. Its real value is m e power 4 by 8 epsilon naught square h cube c multiplied by these quantities 1 by 1 square or 1 by n1 square minus 1 by n2 square. Now, this m is mass of the electron. Really speaking, this mass is not the real mass of the electron, but it is the reduced mass of electron nucleus system. The reduced mass mr is m mass of the electron into mass of the nucleus divided by. In the case of hydrogen, you have got only one proton, that is the mass of the nucleus. In the case of deuteron, you have got one proton and a neutron as the mass of the nucleus. In the case of helium, you have got totally 2 proton plus 2 neutron. So, depending on it, you will have different values. So, this reduced mass can be written as me divided by 1 plus me by mn. That is, this mn is taken out. Now, let us just consider the Rydberg constant on the basis of it. So, Rydberg constant is dependent on mass of the electron and this quantity. So, when you have got hydrogen, it is me by 1 proton. When it is deuteron, it is 1 plus me divided by 2 protons. And when it is helium, it is 1 plus me divided by 4 proton. So, the least value is for helium. Rydberg constant is maximum for helium. Then you have got Rydberg constant for deuteron. Then you have got minimum Rydberg constant for hydrogen. So, on the basis of it, I can write RH is least, then RH 1 2, then RH 2 4. This is the Rydberg constant you have to use. And you know, the wavelength is inversely proportional to Rydberg constant. Wavelength is inversely proportional to Rydberg constant. Therefore, on the basis of it, when wavelength is inversely proportional to Rydberg constant, I will say lambda 1 is maximum. Then lambda 2 is middle. And lambda 3 is least. So, on the basis of it, we have to give the answer. So, lambda 2 less than lambda 1 correct option. Lambda 3 again less than lambda 2 correct option. Lambda 3 less than lambda 1 correct option. Lambda 1 less than lambda 2 less than lambda 3 is the wrong option. Therefore, the correct options are A, B and C.